Welcome all to the course of Data Communication Networking, B7 semester Electronics and Communication Engineering. We are discussing a Unit 5 as a local area network in which a wireless LANs we have discussing. A Part 3 contains a Bluetooth. It is a one type of a wireless LAN. So let's introduce a Bluetooth. A Bluetooth is a wireless LAN technology designed to connect devices of a different functions such as telephones, notebooks, computer, just like our desktop and laptop, various cameras, printer, coffee makers, and so on. The list is very big. The Bluetooth LAN is an ad hoc network, which means that the network is formed spontaneously. The device, sometimes called as an gadgets, find each other and make a network called as an piconet. A Bluetooth LAN can even be connected to the internet if one of the gadget has this type of capacity or capability. A Bluetooth LAN by the nature cannot be a large. If there are many gadgets that try to connect, there is a chaos. Fine. So I think all of you are using a Bluetooth as a ad hoc network in any form. Most commonly form you are using in a Bluetooth earphone or headphone, your smartwatch, your smart band, etc. etc. Our Bluetooth technology has several applications. Peripheral device such as a wireless mouse or keyboard can communicate with the computer through this technology. Monitoring a device can communicate with sensor devices in a small healthcare center. Home security device that can use this technology to connect the different sensors to the main security controller. A conference attendee can synchronize their laptop computer at the computer's conference hall. A Bluetooth was originally started at a project by Ericsson company. It is named for an Harald Betand, the kind of Denmark, who united the Denmark and Norway. Betand translate to the Bluetooth in English. Today, a Bluetooth technology is the implementation of a protocol defined by IEEE 802.15 standard. The standard defines a wireless personal area network called as an PAN operatable in an area of a size of a room or a hall. Means there is a limited capacity of our Bluetooth where the range is limited. So following topic we are going to discuss in this topic is architecture of our Bluetooth, its layers, a baseband layer and L2 CAP. So let's start with architecture. A Bluetooth defines two types of networks, piconet and scatternet. First, piconet. A Bluetooth network called a piconet or a small net when a piconet can have up to the 8 stations. One of these called as a primary and the rest of the call are secondary. All the stationary stations synchronize their clocks and hopping sequence with the primary. Note that a piconet can have only a one primary station over here. The communication between the primary and the secondary can be one-to-one or one-to-many, as you can see in this figure. Although A piconet can have a maximum of 7 secondaries, and additional 8 secondaries can be added a parked state. Means a secondary in the parked state is synchronized with the primary but cannot take part in the communication until it is moved from the parked state. Because only 8 stations can be activated in a piconet, activating a station from the parked state means that an active station must go to the parked state. Means one is in the parked state. Suppose secondary station 2 is not used, so it will be moved to the parked state, and a parked state station is taken place in the place of secondary 2. Fine. So it is our piconet. Second is scatternet. A piconet can be combined to form what is called as an scatternet. Means more than one piconet forms the scatternet. A secondary station in a one piconet can be primary in the another piconet. As you can see in this figure, secondary station from the piconet 1 is the primary station for the piconet 2, which forms the scatternet. In this station can receive the message from the primary in the first piconet and creating as a primary and deliver the data to the secondaries in the second piconet. A station can be member of two piconets. Fine. So it shows the scatternet concept clearly. A Bluetooth devices. A Bluetooth device has a built-in short-range radio transmitter. The current data rate is 1 Mbps with 2.4 GHz bandwidth. This means that there is a possibilities of interference between the 802.11b wireless LANs and Bluetooth LANs. So let's discuss the Bluetooth layers. How many layers are available in our Bluetooth? A Bluetooth uses several layers that do not exactly match those of our internet model. Fine. So figure shows you a complete diagram of our Bluetooth layer. There are several layers, just like our radio layer, baseband layer, L2 CAP layer. Over here audio, data and control is there, profiles is in this section, and lastly application. So let's discuss with a radio layer. A radio layer is roughly equivalent to our physical layer of our internet model. Bluetooth devices are low power and have a range of nearly 10 meters. Band. Which band is used? Bluetooth uses a 2.4 GHz ISM band divided into the 79 channels of a 1 MHz each. Fine. FHSS. Bluetooth uses the frequency hopping spread spectrum. This type of method in a physical layer to avoid the interference from the other devices or other networks. Bluetooth hops 1600 times per second, which means that each device changes its modulation frequency 1600 times per second. A device uses a frequency of only 625 microsecond before it's hopped to the another frequency. The dwell time is 625 microsecond. Which modulation is used in our Bluetooth? To transmit beats to its signal, a Bluetooth uses a sophisticated version of a FSK called as an GFSK. FSK with Gaussian bandwidth filtering. GFSK has a carrier frequency. Bit 1 is represented by the frequency deviation above the carrier. Bit 0 is represented by a frequency deviation below the carrier. 1 is above the carrier, second is 0 is below the carrier. The frequencies in the megahertz are defined according to the following formula. Fc is equal to 2402 plus n, where n is equal to 0, 1, 2, 3 up to 78. For example, the first channel uses the carrier frequency 2402 MHz and the second channel uses the carrier frequency 2403 MHz. Fine. Next layer is baseband layer. So these three are in our radio layer. Next is baseband layer. The baseband layer is roughly equivalent to our MAC sublayer in our LAN. Fine. The access method is TDMA. The primary and the secondary communicate with each other using this tool. The length of the time slot is exactly the same as the dwell time, just like our 625 microsecond. This means that during the time that one frequency is used, seconds or a sender sends a frame to the secondary, or our secondary sends a frame to primary. Note that the communication is only between the primary and the secondary. Secondaries cannot communicate directly with one another. Means a primary must require for a transmission of data from one secondary to the another secondary. A TDMA. Bluetooth uses form of TDMA called as an TDD TDMA. Full form is time division duplex TDMA. TDD TDMA is a kind of a half duplex communication in which the secondary and the receiver sends and the receives the data, but not at the same time. Half duplex concept. Fine. However, the communication for the each direction uses a different hop. This is the similar to the walkie-talkies using the different carrier frequencies. Yes, a single secondary communication. If the Piconet has only a one secondary, the TDMA operation is very simple. The time is divided into the slot of 625 microsecond. The primary uses the even number of slots 0, 2, 4. The secondary uses the odd number of slots 1, 3, 5. TDD TDMA allows the primary and secondary to communicate with a half duplex mode. In slot 0, our primary sends, the secondary receives. In slot 1, the secondary sends, the primary receives. The cycle is repeated. Fine. So over here, primary to secondary, secondary to the primary. In slot 3, primary to secondary, and slot 4, secondary to primary. Means a half duplex concept. Arrow shows the direction of our data. Now a multiple secondary communication. The process is a little more involved if there is a more than one secondary in a Piconet. Again, the primary uses the even number of slots, but the secondary sends in the next odd number slots if the packet in the previous slot was addressed to it. All subsidiaries or secondaries listen to the even number of slots, but only one secondary sends in any odd number of slots. So let's take an example of this figure. In slot 0, the primary sends to the frame to secondary 1 over here. In slot 1, only secondary 1 sends the frame to the primary because the previous frame was addressed to the secondary 1. Other secondaries will be silent, just like this. These two are silent. Fine. In slot 2, the primary sends the frame to the secondary 2 over here. In slot 3, only secondary 2 sends the frame to the primary because the previous frame was addressed to the secondary 2. other secondaries will be silent. This cycle continues. We can say that this access method is similar to the poll select operation with a reservation. When the primary selects a secondary, it also polls it. The next time the slot is reserved for a polled station to send its frame. If the polled secondary has no frame to send, the channel is silent. Next is physical links. Two types of links that can be created between the primary and the secondary. First is SCO and second is ACL. SCO means synchronous connection oriented and ACL means asynchronous connection less link. So let's discuss the SCO. This link is used when avoiding a latency, just like a delay in our data delivery, is more important than integrity, error free. Means a data delivery is most important than an error free delivery. In an SCO link, a physical link is created between the primary and the secondary by reserving a specific slot at the regular intervals. The basic unit of a connection of two slots, one for in each direction. If a packet is damaged, it is never retransmitted. SCO is used for a real-time audio where avoiding a delay in our all important. A secondary can create up to the 3 SCO links with a primary, sending digitalized audio just like our PCM at a 64 kbps in each link. Fine. Next is ACL. An asynchronous connectionless link is used when the data integrity is more important than avoiding a latency. In this type of a link, if a payload encapsulated in the frame is corrupted, it is retransmitted. In the first case, there is no retransmission concept is there. Over here, retransmission concept is there. A secondary returns an ACL frame in then available of an odd number of slots if and only if the previous slot has been addressed to it, as we have seen in the last topic. An ACL can use 1, 3 or more slots and can achieve a maximum data rate of 721 kbps. In the SCO, there is a data rate of 64 kbps. Over here, ACL have a 721 kbps. So what are the frame format of our Bluetooth? A frame in the baseband layer can be one of the 3 types: 1 slot, 3 slot or 5 slot. A slot, we are said before, is 625 microsecond. However, in a 1 slot frame exchange, 259 microsecond is needed for hopping and control mechanism. This means that a 1 slot frame can last only 625 minus 259 is equal to 366 microsecond. With an 1 megahertz bandwidth and 1 beats per second per hertz, the size of the 1 slot is 366 bits. The 3 slot frame occupies 3 slots. However, since 259 microsecond is used for hopping, the length of the frame is 3 into 625 minus 259 is equal to 1616 bits. A device that uses a 3 slot frame remains at the same hop. For our entire 3 slots, even though only a 1 hop number is used, 3 hop numbers are consumed. That means the hop number for each frame is equal to the first slot of the frame. A 5 slot frame also uses 259 bits for a hopping, which means that the length of the frame is 5 into 625 minus 259 is equal to 2866 bits. Our figure shows the format of the 3 frame types. So let us discuss this frame format types. First is access code. This 72 bits field normally contains a synchronization bits and the identifier of the primary to distinguish the frame of the one Piconet from the other header. This 54 bits field is repeated 18-bit pattern. Each pattern that has following subfields just like this: address, type, FAS, HEC. First is address. A 3-bit address subfield can define up to 7 secondaries, 1 to 7. If the address is 0, it is used for a broadcast communication from the primary to the all secondary. Type. A 4-bit byte subfield defines the type of the data coming from the upper layer. F. This 1-bit subfield is for a flow control. When set is to 1, it indicates that the device is unable to receive more frames, means buffer is full. A. This 1-bit subfield is for the acknowledgement. Bluetooth uses stop and wait ARQ. One bit is sufficient for an acknowledgement. S. This 1-bit subfield holds the sequence number. Bluetooth uses the stop and wait ARQ. 1 bit is sufficient for sequence numbering. HEC. The 8-bit header error correction subfield is a checksum to detect errors in each 18-bit header section. The header has 3 identical 18-bit sections. The receiver compares these 3 sections bit by bit. If each of the corresponding bits is same, the bit is accepted. If not, the majority opinions rules. This is the form of forward error correction for a header only. This double error control is needed because the nature of the communication via air is very noisy. Note that there is no retransmission in the sublayer. Last is payload. This subfield can be 0 to 2740 bits long. It contains the data or a control information coming from the upper layers. Next is our L2CAP, means a logical link control and adaptation protocol. This L2CAP means L2 is equal to 2L, fine, logical link. It is roughly equivalent to our LLC sublayer in our LANs. It is used for the data exchange on an ACL link, SCO channels, which not uses the L2CAP. Our figure shows the format of the data packets in this level. The 16-bit length field defines the size of the data. In bytes coming from the upper layer, the data can be up to 65535 bytes. The channel ID defines the unique identifier for a virtual channel created at this level. The L2CAP has a specific duties just like our multiplexing, segmentation and reassembly, quality of service, QoS and group management. Fine. So we discuss each one briefly. First is multiplexing. An L2CAP can do multiplexing. At the sender side, it accepts the data from one of the upper layer protocol, frames them and delivers them to the baseband layer. At the receiving side, it accepts the frame from the baseband layer, extracts the data and delivers them to the appropriate protocol layers. It creates a kind of a virtual channel that we will discuss in a higher level protocols. Second is segmentation and reassembly. The maximum size of the payload field is the baseband layer is 2774 bits or 343 bytes. This includes 4 bytes to define the packet and packet length. Therefore, the size of the packet that can arrive from the upper layer can only be 339 bytes. However, the application layer sometimes needs to send a data packets that can be up to 65535 bytes. The L2CAP divides these large packets into the segments and adds then extra information to define the location of the segments in the original packet. The L2CAP segments the packet at the source and reassembles at the destination. QoS, quality of service. The Bluetooth allows the station to define a quality of service level. For the moment, it is sufficient to know that if there is no quality of service is defined over here. Bluetooth defaults to what we call is as best effort service. It will do its best under the circumstances. Last is group management. Another functionality of an L2CAP is to allow a device to create a type of a logical addressing between themselves. This is similar to the multicasting. For example, 2 or 3 secondary devices can be part of a multicast group to receive the data from our primary. Fine. So it is the end of our session. So let's revise our discussion. We have started our discussion with our Bluetooth. Architecture contains a piconet where a primary and the secondary maximum 8 number of station in a one piconet. Then another type of architecture is scatter net where one secondary in first piconet is the primary for the second piconet is forms the scatter net. We have discussed the various layers of our Bluetooth where the radio contains the band, FHSS and modulation techniques. Baseband contains TDD, TDMA. Fine. We have discussed single secondary communication, then multi-secondary communication, 2 type of physical links, SCO and ACL, a frame format for our Bluetooth is discussed, L2CAP data packet format and its roles in our Bluetooth: multiplexing, segmentation and reassembly, quality of service and group management. So it is a question for you. Write them in your notebook and send back it to me as per the given direction. Okay students, see you in the next session.